All right. So this next set of screens, 7 through 13, I think, are basically based on the same graph. And we're going to evaluate the limit of this graph at certain points and the value of the function too, right? So this first one, and it goes, this screens go left to right. So this first interesting point is at -6 here. And so the first limit asks us to, or the first limit denotes that we're approaching -6 from the left, right? I know that because of that negative there, that superscript negative. So if I approach from the left, if I follow this graph from left to right towards -6 on the left side of -6, right? Um, then I can see that my output is 4, right? My output gets closer and closer to 4 as I get closer and closer to -6 from the left, okay? And so on the left side of -6, we're going to 4. So I'll just type in a 4 there. All right. Now we're approaching from the right side of -6. So I want to approach -6 from the right, and I can see that it gets closer and closer to 4 as well, right? It's getting closer and closer to 4 as my output's getting closer to 4 as my input's getting closer to -6, right? So I'm going to type in a 4 here as well. All right, and then here's a two-sided limit, right? This one doesn't have a plus or minus superscript, so that means it's a two-sided limit. So basically, I evaluate from the left and the right. If they're the same, then that's my answer. If they're not the same, it's D and E, right? So in this case, they are both 4. So that's the two-sided limit is also 4. All right. And remember now, f of -6 is what is the value of the function at that point, right? And so this is where it differs, right? This is where you see the difference in a limit and the actual function. So at this point, there's an open circle, right? So the function actually never, even though it approaches 4 from both sides, it never gets there. So there's an open circle there. And the actual value of the function at that point is this. So it's -6 at when x is -6, y is actually -1, right? That's our output. So -1 is what we put in here. Okay, that's the output when the input equals -6. All right, so that's how we do that one. So let's check out the next one. Same graph. Now we're evaluating at -4. Okay, so now we're looking at this input value. So now we're approaching -4 from the left, right? That's what that means. And so as we go from the left of -4 and we get closer and closer to -4 on the x-axis, we see that our y values get closer to 2, right? So we get 2 there. As we approach -4 from the right, again, our values get closer and closer to 2, our output values. So we're going to put a 2 there. The two-sided limit, the same, right? They're both the same. So it's going to be equal to that value, which is 2. And then the actual value of the function at -4, if we look for where the dot is or the closed circle, it actually is right there, right? Even though that doesn't, it doesn't actually compute there. We can see that they do link up, right? It does meet. They do meet at 2. So it's going to be 2 here. All right. Okay. So we saw one where the limit, we had a limit that existed, but the function wasn't the same at that point, right? And then we saw one where the function is the same as what the limit was. Let's see what happens next. It's the same one. Yeah, we did that one. So screen 9. So now we're looking at what happens at 0. So at 0, we have an asymptote, right? And so what's happening as we approach 0 from the left here for this first one is as we get closer and closer to 0 on the x-axis, our y value just keeps increasing and increasing off the charts, right? So it goes up, and as far as we can tell, it goes up forever. So that's going to be positive infinity. As we take a look at the right side of 0 on this function, if we keep getting closer and closer to 0 from the right side of 0, then we can see, again, that goes off the graph, but this time in the negative direction, right? It goes down forever. And so the limit as x approaches 0 from the right is actually negative infinity. Since these do not match up, that means that our two-sided limit is going to be D and E, does not exist. And so the limit as x approaches 0 of h of x, the two-sided limit is D and E. The actual value at 0, the function at 0, I don't see any closed circles here. It's an asymptote, and generally at an asymptote, the value that at that point is going to be undefined. Okay, so we'll type in undefined. Actually, let me do that not with that, but with my keyboard here. So and for these, typing all lowercase would be great. I just messed that up. Can't see what I'm typing because I have a on-screen keyboard. But anyway, so undefined. There we go. All right. And so good. Now, I won't take off for spelling and things like that. So as long as I can pretty clearly tell it's under, you say undefined, that's good. But the way I have Desmos auto grading, it's all lowercase, and so that would be helpful in terms of just making sure the grade, it's auto grading, just makes it a little bit easier. So if you do lowercase, that'd be great, and spell it correctly. All right. So next one, we're looking at what happens at 1. Now this one is interesting. This one's kind of one of those I put on there because it's not a common limit question, because usually we're looking at these kind of interesting points and what happens at, when you have these breaks in the function, or when you have holes in the function and asymptotes and things like that. But this one is just kind of a regular spot in the function. When as x approaches 1, that's around right here on the graph, right? So we can see there's no kind of unusual behavior here, right? So that's one of the reasons why I chose this point, is just to kind of show you that. Remember that a line is a collection of points, right? And on Desmos, you can kind of see that as you drag, like there's an infinite amount of points, everywhere between any 2 points on a line. And so as we approach 1 on the x-axis from the left, we can see that our output gets closer and closer to 2, right? And so this would be 2 here. All right. As we approach from the right side of 1 and get closer and closer to 1 on the x-axis, our output again gets closer and closer to 2, right? So this would be 2. And so again, our two-sided limit from the left, it's 2. From the right, it's 2. So that means our overall two-sided limit is 2. And then f of 1 at that point, even though we don't see a closed circle, remember that there is a closed circle there. This is a collection of closed circles is what a line is, right? And so at 1, x actually does equal 2. So we just put 2. Okay. All right. So it's similar to, I forget what screen it was. I think it was 8, where the limit was the same as the actual point, just like this one. Similar thing that happens here. We just don't see that kind of accentuated closed circle right here. It's just a point on the line, right? And it happens to be, not signified with a larger closed circle. So anyway, all right. So that's that one. Let's check out 11. So in here we're looking at another asymptote. So as x approaches 2, so we have this asymptote on the right side, or excuse me, on the left side of 2. We can see it goes up and up forever, as far as we can tell. So positive infinity. On the right side, as x approaches 2, we're going up forever. So positive infinity. And since those are the same, that means our two-sided limit will also be positive infinity. And the value at 2, again, when we have an asymptote, if we don't see a closed circle anywhere, that's just going to be undefined. Okay. So I'll let you type in undefined just so I don't take up your video time just for me typing with my on-screen calculator. So that'll be undefined right there, right? Okay. And then last but not least, we have screen, or actually there's one more after this, but this is our last limit screen for these ones, for this graph. So now we're looking at 5. So 5, we see this break in the function, right? And so as we approach 5 from the left, we can see that our output is getting closer and closer to 2. Now, this one actually is a little above it, and I saw some people in class putting 2.1. That's totally fine if you do that. But I meant this to, I'll make these so that they're pretty close to integer values, so you don't have to kind of approximate. But if you approximate and get 2.1, or you're 2.05 or things like that, you'll get full credit, because there is some room for interpretation there. But I meant that to be 2, just to make it easy. All right. And then as we approach 5 from the right side, we can see that our output is actually approaching 0, right? So when we get there, we see it's undefined, but as we get closer and closer to approaching 0, we can easily visually see that trend, or you can trace it out using Desmos. So that the two-sided limit here, since it's different from one side than it is from the other, the two-sided limit is DNE. So we'll just type in DNE. Okay. All right. And then F of 5 at that point. So where is the closed circle here? And it's actually here again. Again, that's a little above 2, but you can just call it 2. If you call it 2.1, that's totally fine. You'll get full credit. Okay. But I'm going to call it 2. All right. So that's basically how we evaluate limits graphically, just by kind of visualizing what happens as we get closer and closer to a point on the x-axis, what happens to our input, or excuse me, what happens to our output on that function as our input gets closer and closer to that given value from whatever side it indicates. Okay, and then this last one is asking us to find the equations of the vertical asymptotes on this function. All right. So we have 2 of them. One is right here where x equals 0. So remember that we don't just write 0, we put x equals 0. Okay. So, and it's always x equals for a vertical line. So x equals a constant is a vertical line. So x equals 0 is this vertical asymptote. And then this vertical asymptote is where x equals 2. And you can see x always equals 2 as y changes. And so that's why it's the equation x equals 2. All right. And those are only 2. These other ones are wrong answers. Okay. All right. So that's how to evaluate limits graphically. And I may not give you this many screens on the actual test, but I wanted to show you kind of all the possibilities that you might see when we get to the test. I want to show you in the practice test. So instead of having this many screens, it may be 2 or 3 instead of 4 or 5 or whatever it was.